Hello my dear students, welcome to Diksha Karnataka YouTube channel, and here is the most awaited video that you have requested, the most important topics chapter wise for physics for your second PU pre-board exam. Your pre-board exam already started. Some of you have already written your tests, but I hope that your physics exam is somewhat not yet done. So before exam, what are all the topics, what are all the concepts and derivations if you have to revise, also what are the numerical questions or formula based questions that you have to revise, everything in this video for most important and medium important chapters. That is I think 11 chapters out of your 14 chapters we are going to discuss here. If you are someone who is not super strong in physics, I also going to recommend few of the chapters from where you can study. So watch till the end. If you are a strong or super strong students who want to score well in your pre-board exam, then also you have to watch it. If you are someone who is weak and not so strong in physics, you have to watch this video. So because I am going to discuss all the important concepts from all the chapters of physics. So first chapter is electric charges and field, and in this chapter what are all the important concepts? Important concepts are Coulomb's law, properties of charge, properties of electric field lines, very important, torque on acting on a electric dipole. These are all the concepts. Gauss's law, these are all the concepts. So formulas and small questions based on this will come definitely. Now what are the application part? Application part means the formulas that you have to remember, or based on this concept numerical questions, highly probably numerical questions will come, or they will ask you what is the formula for this and explain the term. So these type of questions are expected from this application parts. So basically here formulas are given. In this case, concepts means Coulomb's law, obviously the statement and the associated formula will definitely be there, but it will be first there will be a concepts, right? So first concept is the important, then we have the formula. So here we have only the formulas are important. Derivations maybe at times some derivations might come, but mostly the formulas, and based on that some numerical questions or some explain the terms type of questions will come. Now derivation, it is clear cut, obviously it is a derivation question. Now end result of the derivation can still be used in case of a numerical question, but derivation, when I am saying derivation, you have to practice the derivation for these three things in this chapter. What are those? Electric field due to a dipole, two different positions, okay, on the axis, on the perpendicular bisector, both are important from this chapter. Electric field due to a long straight wire, long straight charged wire, not current carrying wire. Electric, basically application of Gauss's law. Again electric field due to a spherical shell, another application of Gauss's law. All are important from this chapter, and this chapter is must for all type of students. If you are strong, if you are average, if you are weak, this chapter is recommended for all the students, okay. You cannot skip this chapter. Now next is electrostatic potential and capacitance. This is also another important chapter. Again this chapter is recommended for all type of student, no matter what is your expectancy, but this is the competency, sorry, whatever your competency is, maybe you strong, weak or average, this chapter is again recommended for all type of student. Electric potential is the concept, key potential surface, very important concept from this chapter. Electrostatics of conductors. So there are few points on electrostatics of conductors. You can check that out. I have done in Brahmastra series, or you can follow my Decode NCERT series. There also I have discussed these properties. Torque on an electric dipole. So this formula is important. The concept is also important. Polar and non-polar molecules, very important question will come, okay, from this concept as well. Now applications part, potential energy of a system of charge. A lot of questions come like there is a triangular shape or rectangular shape where the three charges are there. What is the potential energy at the midpoint or on the other corner? Like this type of questions are coming from these concepts, okay. This is a very important important. Capacitors in series and parallel. Derivations, okay, maybe a 2 or 3 marks question might come for this part, but more than derivations, numerical questions or concept based questions might come from this part. But yes, derivation might come as a 2 or 3 marks question. Energy stored in a capacitor, the formula you have to remember and explain the terms is very common question. Okay, energy density also was asked in a 5 mark question as a part question, not the derivation. Derivation is not important for this, but the final result is important. Okay, now in the derivation, obviously relationship between E and V, electric field and potential, that is E is equal to dV by dx or dV by dl. That is very, very important. There is a negative sign there. And electric potential due to a point charge, this is a 5 mark derivation, this is a 3 marks derivation. Okay, and this is a 5 mark derivation. Okay, so this is a 3 marks derivation, whereas this is a 5 mark derivation. Okay, capacitance of a parallel plate capacitor, this was asked as a part question. Obviously 3 to 4 marks, 3 marks, 3 to 5 marks, anything can come from this derivation. This is also very, very important. Potential due to a dipole, potential due to a dipole is important. Normal potential due to a dipole, I have done this in my all derivations video, you can check that out. Potential energy of a dipole in an external field, this is also important. It's a 5 mark question. This is also very, very important. I have done it in my Brahmastra series, you can check that out. Now next is current electricity. This is also recommended for all types of student. This is also super important chapter. So here drift velocity, all the formulas, equations related to drift velocity, definition of drift velocity. Okay, mobility, what are formulas related to mobility and the definition of mobility, relaxation time, definition of relaxation time, as well as the formulas, whatever is related to relaxation time is related by symbol tau. So everything you have to study from there. Then again Ohm's law and its limitation, very, very important, Ohm's law and its alternative form. Okay, so J is equal to sigma E, that is also important. Okay, alternative form of Ohm's law and its limitation, very, very common question. Mention 2 limitations of Ohm's law, mention 3 limitations of Ohm's law. Okay, super important. Next, current and current density. So current density is given by J. So current and current density, relationship between current and current density, difference between current and current density, that is also very, very important. Electric power P is equal to VI, important concept. Based on that concept, some questions might come. Resistivity, definition of resistivity. Okay, what is resistivity and how it varies with temperature. These are the important concept from this chapter. Now application part, resistance of a conductor. Obviously resistance of a conductor, R is equal to rho L by A. Right, this formula, resistance of a conductor means this formula. Obviously there are basic properties of resistances that you already know, and this formula is very, very important. Kirchhoff's laws, both Kirchhoff's current law and voltage law, both are important. Okay, based on that a lot of numerical questions will definitely come. Statement might come, what is conservation, which one is based on conservation of charge, which one is based on conservation of energy. So Kirchhoff's law is also very, very important. This chapter itself is a super important chapter. 12 to 13 marks comes from this chapter alone. Okay, energy stored in a capacitor, another important concept. Okay, I think this is from the last chapter, this is not from this chapter. Okay, cells in series and parallel, Wheatstone bridge. So only 2 derivations are there, actually 3 derivations. Cells in series and cells in parallel, both are important, and Wheatstone bridge, this is also very, very important from this chapter. So these are the important concepts from this chapter, and this chapter is important not only for numericals but also for derivations. Both questions will come from this chapter. This is a very, very, very important chapter. Next is moving charges and magnetism. This is also a very important chapter, you cannot skip it. This is also for all type of students. So first 4 chapter is recommended for all types of student, no matter what you are studying. Right, Lorentz force, motion of a charge in a magnetic field, Biot-Savart law, galvanometer, ammeter to galvanometer and galvanometer to ammeter conversion. So these are all the important concepts from this part. What are the applications? Solenoid, the formula for solenoid is important. Based on that 2 marks, 3 marks question, numerical questions will come. Okay, circular current loop and magnetic dipole. So circular current loop acts as a magnetic dipole. What is the magnetic dipole moment, etc. What is the dependence on the current, what is the dependence on number of turns. So everything is important. Next, Ampere's law. Ampere's law is also a very important concept. Okay, statement and explanation, formula, etc. is very important. Okay, and based on that formula also maybe numericals will come. Magnetic field on a axis of a circular loop. This is a very superstar question from this chapter. Okay, very important question. So this is a high probability that this will come in your derivation part. Force between two parallel bars is also important. Okay, and torque on a rectangular current loop. This is a derivation that was recommended in your model question paper. So this question might come as well. So everything is important from this chapter. You cannot skip this chapter as well. Now let's move into the next chapter, Magnetism and Matter. This is a small chapter. If you have studied this chapter before, definitely you want to revise it. If you have not studied this chapter, you can skip if you are a weak student. Okay, Magnetism and Matter is a small chapter. I can ask you to skip this chapter because a lot of things are important. Only thing that you have to study from this chapter is this: properties of magnetic field lines. Out of the properties of magnetic field lines, properties of equipotential surface, and properties of electric field lines. There are three types of field lines. Okay, equipotential surface, properties of equipotential surface, properties of electric field line, properties of magnetic field line. One question will definitely come in your exam, highly probably. Okay, now there are so many districts in Karnataka, and all the districts have different types of question paper setter, and they all do different question paper setter. So maybe in your district you might not get this question, but most out of one out of two states, you are definitely going to two district definitely going to come this question. This question is very important, right? So properties of magnetic field lines, you just have a look. Okay, and difference between paramagnetic, diamagnetic, and ferromagnetic. These are the two important concepts from this chapter. For weaker section of the students, I ask them to study these two parts. You can skip rest of the parts. Okay, now Gauss's law of magnetism, important concept. Okay, why magnetic field lines are closed, etc. That is being explained from this. Magnetization, definition of magnetization. Okay, definition of magnetic susceptibility, definition of magnetic permeability, the relationship between susceptibility and permeability, that is also very important. Okay, the magnetic dipole in an uniform magnetic field, what happens to that, the formula and the explanation, that is also very important. And this is a small chapter, so no derivation is from this chapter. This chapter, only two concepts I recommend for all the students. Otherwise, if you are you have already completed this chapter at least once, then you can revise this concept from this chapter. If you have not done, you have not studied this chapter, no need to study except these two concepts. Okay. Now, electromagnetic induction, another small chapter, very small chapter, but it has all the portions. So this is a very small chapter. You can study even if you are weaker section of the students. This is a scoring chapter. 6 marks, 4 to 6 marks can come from this chapter. So that's why I recommend this chapter, even though maybe you have not studied this chapter. So Faraday's law and Lentz's law of induction, they are all important. Okay, inductance, definition of inductance, self-inductance, mutual inductance. Okay, this is also important. Now Faraday's coil magnet experiment, this is very important application of the, even though there is no formula involved, even though there is no calculation involved, but this is a important experiment. That's why this is an application, right? AC generator is another application. You can read it just a bit and understand what is the formula involved. Then this derivation is super important. This is a 3 marks derivation, but most likely it will come. This is a super important derivation. Okay, motional EMF force. Okay, so what is that? Epsilon is equal to BVL. This is a very important derivation from this chapter. Okay, a small question, but most likely will come. Next is alternating current. This is also an important chapter, and if you have seen my videos, this chapter I recommend for numerical questions, right? So this chapter is super important for numerical questions. But if you have not studied this chapter at all, because people think that this is a hard chapter, difficult chapter, actually it is not. If you have not studied this chapter at all, right now you can skip it. But those who want to score good, score well, definitely this is a scoring chapter. Now decision is up to you. I am not neither recommending, neither discouraging anyone, but this is a very scoring chapter. Especially you can score 5 marks of numerical from this chapter. So only thing that you have to concentrate from this chapter is about numericals. Apart from numericals, RMS voltage current concept you need to know, because sometimes in the numerical section only they will ask what is RMS voltage, what is RMS current. So you have to know what is the relationship. And sometimes it might come as a MCQ question as well, right? Now AC power, formula for AC power, how it is differs from the DC power, so that you have to remember. Power factor is also an important concept, how the power factor determines how much power is being absorbed in the circuit. These are all for small short answer type questions, or MCQ and fill in the blanks type questions. Now this chapter is very, very important for all the numerical questions. So all the concepts here are related to numerical questions. AC applied, so I have not given anything which is not relevant for a current chapter, right? So you have seen that. So AC applied to a resistor, inductor, capacitor, all the formulas, what is the phase relation, everything you have to remember for these 3 different circuits. Other than that, nothing you have to do. Series LCR is very, very important concept. In series LCR, actually these are all the related things related to series LCR circuit that you have to remember: impedance, voltage, phase, current. Okay, so these are the formulas that you have to remember. What is the formula for impedance, what is the formula for voltage, what is the formula to calculate phase, what is the formula to calculate current. And then resonance itself has condition for resonance and resonance frequency. Okay, these 2 things you have to remember definition as well. So these are the important concept from this chapter, super scoring chapter. But if you have not studied it, you can skip it, because the concept is slightly maybe overwhelming for you. Right now, next is ray optics, another important chapter and simple, easy chapter. I recommend this chapter for all the students. Okay, maybe you are strong, weak, or just average. This chapter is recommended for all the students. This is a super important chapter. What is there in between? In the concepts, we have total internal reflection. We have already learned that in our class 10th. So simple thing. Sign convention also we have learned in class 10th. But sometimes in your pre-board exam, even though I have not seen this question in final exams, but pre-board exams they tend to ask this question too often. Okay, so this is a common question. Sign convention for mirror, sign convention for lens, or normal sign convention, Cartesian sign convention. So that diagram that is given in your book, you have to draw the diagram and explain that along the positive x-axis it is positive, along the negative x-axis is negative, along the positive y-axis is positive, along the negative y-axis is negative. So like that, only very small description, but 2 to 3 marks question might come from this concept. This question is important particularly for pre-board. Final exam maybe not so. Now concepts of telescope, microscope, so objective, which one is objective, which one is eyepiece, so what is the relationship, they based on this not many super important questions have come, but relationship between eyepiece and objective lens have come in the past. Now application part, this formula, the derivation and application of this formula is very, very important. So this is a very important part. Okay, maybe there will be a numerical question where you have to apply this concept. Okay, mirrors and lens equations are important. Based on that, 2 to 3 marks numerical question might come from this chapter. Power of a lens also very, very important, and I have seen a 5 mark question coming from this power of lens concept in pre-board last year. Okay, so power of lens also very, very important concept. Now derivation, in terms of derivation is most likely there will be a derivation from this chapter. First of all, refraction through a spherical surface and lens maker's equation. These 2 are the most common question from this chapter, but the third one is also not super uncommon: refractive index of a prism, angle of minimum deviation. So how to calculate the refractive index of a prism in terms of prism angle and angle of minimum deviation. This is also very, very common question. Okay, and numerical also I have seen 5 marks numerical also from this concept. So this is also an important concept, you cannot skip that, right? Next is wave optics. Wave optics is a simple chapter, but if you have not studied it, you can skip this chapter. This chapter is only for students who want to score higher. Okay, for average or below average students, you can skip it. If you think I don't have time to complete this chapter, don't waste your time in this chapter. So for important concepts from this chapter are Huygens principle, coherent and incoherent sources of light. Then we have interference of Young's double slit experiment. There are two things you have to remember. General expression for interference, that when two lights are interfering with each other, what is the intensity of the light. Okay, that formula you have to remember, and what is the condition for maxima and minima for Young's double slit. This is also important. Diffraction condition for maxima and minima. Okay, one more concept that is I missed is polarization. Polarization is also important concept. Malus law. Based on Malus law, some concept, state a Malus law and explain the terms. That type of question also has come. Now derivation, in the derivation section, refraction of plane wave, Snell's law, very important. Okay, reflection of plane wave, laws of reflection, this is also very important. Okay, these two derivations, this one is a 5-mark derivation, this is a 3-mark derivation, but both type of derivations are common from this chapter. And as I said, this is for students who want to score more, at least 80-90%. For them it is recommended. If you are just want to pass the exam, or maybe below 50 is okay for you, below 50 including practicals, if it is okay for you, then it is, you have to you can skip this chapter. Including practicals, if you want to score 50 plus or 60 plus, definitely this is a chapter you have to study. Now next is dual nature of radiation and matter. This chapter is simple, easy, scoring chapter. That's why I recommend this chapter to all the students. Okay, this chapter is obviously simple chapter. As you see, there is no super important derivations are coming from this chapter. Yes, 5-mark question comes, but 5-mark questions are split type question, 1 mark plus 2 mark plus 2 mark, or 2 marks per 3 marks question. So these are all small questions. You can study. You can check my Brahmastra series. I have properly explain all the important concepts from this chapter. Photoelectric effect, there are different observations from photoelectric effect. Then photoelectric effect, Einstein's explanation is also very important. Effect of potential on photoelectric current, so different graphs are there. What will happen if you apply external potential? Okay, what is stopping potential, what is maximum saturation current? Okay, particle nature of light. Particle nature of light is also important, why light is behaving as a particle. Okay, all, and in the application part, photoelectric equation. Based on photoelectric equation, numerical questions are very common. Also de Broglie wavelength. De Broglie wavelength is also very important, that is wave nature of particle. Okay, so de Broglie wavelength talks about wave nature of particle. Particle nature of light talks about, that is Einstein's explanation, that talks about when light behaves like a particle. So these are also very important. Small chapter, less concepts to study, but very scoring chapter. That's why this is a recommended chapter for all the students. Next chapter is last chapter. This chapter is also recommended for all the students, because from this chapter you are expected to get a full 5-mark question. Very important. A full 5-mark question is expected from this chapter alone, and out of the 5 mark there is only 2 questions that you have to study. What is that? Half wave. Even though I have mentioned it is under the derivation part, this is not derivation, this is just explanation. Okay, half wave and full wave rectifier. Okay, half wave and full wave rectifier are the most important derivation from this chapter. So at least if you don't get any time, you study these two, half wave rectifier, full wave rectifier. Okay, in pre-board as well as in board, both are important. In board, full wave is more commonly asked than half wave. Maybe full wave was asked 6 times, half wave was asked maybe 4 times in last 10 years, but in pre-board they are both are very common. Okay, now in the other concept part, band theory, why something behaves conductor as conductor, something behaves as insulator. So in terms of band theory, this is very commonly asked as a 2-mark question. okay, and in objective and numericals, objective and fill in the blanks as well. P and N type semiconductors. What is a P type semiconductor? What is N type semiconductor? What type of material you have to dope? So these are the common questions for objective question. Okay, so this is a important concept. Junction diode. Okay, what is junction diode? It's a graph. Then what is junction potential? What is depletion region? So these are what is the charge in depletion region. These are the common concept from this chapter. This is a small chapter and scoring chapter again. So I recommend this chapter to all the students. Okay, so I hope this is clear. Apart from that, there are 3 chapters that I have not discussed. One is electromagnetic wave, another one is atoms, and last one is nucleus. Okay, if you have studied those chapter, you can revise those chapter. Okay, otherwise you can skip those chapter. For example, in nucleus chapter, properties of nuclear force is very important concept, right? So those are a few questions that might come in your upcoming pre-board exam. Other than that, Rutherford explanation, Rutherford experiment, Bohr's observation, those are slightly complicated topics, but not super scoring. So that's why I have skipped those chapters for considering my weaker section of the class. Similarly, electromagnetic wave also not super important topics are there. 2 to 3 marks question comes from the chapter. Only one formula, that is speed of light is equal to 1 by square root of epsilon naught mu naught. So that is only one formula from that chapter, and some applications of electromagnetic waves are there. So I hope you enjoyed this session, and if you have any questions, any doubt, don't forget to mention that in the comment below. I'll try to respond as early as possible. Also, don't forget to mention how was your pre-board exam, if you have already given it, and if you are going to give it, how much preparation you have done. Don't forget to mention that as well.